Hello everyone, welcome to today's class. We'll be continuing with the chapter of limits, and now we'll start with the topic known as trigonometric limit. Okay. So first of all, let me give you the basics that will be used in this. That is, limit x tends to 0, sin x by x is 1. Another formula, limit x tends to 0, tan x by x is also 1. Okay, and for cos we will not be having this kind of identity, because when x is tending to 0, cos is already 1. Okay, now let's see how to use it, because using these as something different. Look at the question. Limit x tends to 0, sine 3x by x. Okay, all right. Now the idea is, for using this identity, whatever is present inside the sign, same thing should be in the denominator. Means sine something upon same something. So if 3x is present here, the denominator should also be 3x, but it's not. So I'm writing 3 in multiplication of denominator. So to adjust that, I need to multiply another 3 here. So if we require 3x in the denominator, we'll put 3 and adjust it. Okay. Now this becomes a standard limit. Now sine something upon same something, limit x is tending to 0. That's 1 into 3. So answer is 3. This is how we will use this formula. Okay. Next, limit x tends to 0. This time let's say sine 5x upon 2x. Okay. So same thing, limit x tends to 0, sine 5x. Denominator is 2x, but what do you need? You need 5 now. So you write down 5x first of all, then adjust that 5. Okay, and but it was already 2x, so just write down 2 here. Rather than writing 2x, write down x first and then 2 here. Now this is again standard, sine something upon same something, limit x is tending to 0. So this is becoming 1. This was 1. This was also 1. So 1 into 5 by 2. That's the answer. Okay. Next, limit x tends to 0, sine ax upon sine bx. Now in order to apply limit for sine, you need sine something, that is sine ax upon same something, but ax is not there. So let's multiply and divide. Let's divide it by ax. So I have divided by x, so I have to multiply also by x. Okay, so the question remains the same. And the denominator also having sine bx. So same thing here also. I'll divide it by bx so that the limit works, and then multiply by bx also. Okay, this is the whole denominator. X was tending to 0. Now this particular limit, this particular limit, they are both 1. Sine something upon same something, sine something upon same something, both are 1. So what you are left with? 1 into ax by bx. X also cancel it, so we get a by b as the answer. Okay. All right. Next, limit x tends to 0. This time sine square ax upon sine square bx. Okay. So just square is there. So what do you do? Limit x tends to 0, sine ax by sine bx. If you write down, I think 2 times now, that will be better. You can directly do it also, or write down 2 times. Sine ax, sine ax. Okay. Denominator is sine bx, sine bx. Okay. Then divided by ax, so multiply by ax, divided by bx. So in order to adjust, multiply by bx. 1, 1, 1, 1. Okay, sine something upon same something, sine something, same something, same thing. So this is 1 into, numerator is a square x square, denominator is b square x square. X square also cancels. Answer is a square by b square. Okay. Another simple question in terms of now number. Limit x tends to 0, sine square 3x upon x square. So what you can do this time, is you can write it 2 times also, but I'll just do it in a different way, because what if you get sine raised to power 10x? Then you don't write 10 times. Rather than you rewrite this as sine 3x by x, and limit x tends to 0. X tends to 0, and just put a whole square on it. Okay. Like this. Now, in order to solve this, sine something upon same something. So 3x has to be in the denominator, but it's happening inside the square root, inside this whole square. So you multiply also with 3 inside the whole square. Now this first part, this is solved. Sine something upon same something, so that's 1. Okay. And what you are left with is 3 square. What is 3 square? 9. So 9 is the answer. Okay. Basic. Let's see next level. The next level goes like this. 1 minus limit x tends to 0, 1 minus cos 2x by x square. Now remember from Tigo, I specially emphasized on one particular identity. I said that you will be using that again in limits. That identity was 1 minus cos 2 theta, 1 plus cos 2 theta, both. Okay, 1 minus cos 2 theta is 2 sine square theta. Okay, do the half of the angle. Okay, 1 plus cos is 2 cos square, although it will not be used this time. Most of the question will, majority question will be like this only, 1 minus cos, 1 minus cos. So let's rewrite this. So it becomes limit x tends to 0. It becomes 2 sine square. Half of the angle is 2x, so half of that is x upon x square. And this is pretty much we have solved. Okay, this sine x by x whole square. Yeah. So limit x tends to 0, that becomes 1. So 2 into 1. Sine x by x is 1. All right, that's 2. That's the answer. Next, based on this only, 1 limit x tends to 0, 1 minus cos x this time upon x square. Okay. Now what does that become? This becomes 2 sine square, half of the angle. So x is there, so half of that is x by 2 upon x square. Okay. So now what do? Limit is going x tends to 0. So this becomes limit x tends to 0. You can rewrite this as 2 sine x by 2 by x whole square, and then do the same adjustment, sine something upon same something. So since you have divided by 2, you will multiply also by 2, and this limit is already solved. So this becomes 2 into 1 by 2 square, which is 1 by 2, and that's your answer. Okay. All right. Now arbitrary constants. Limit x tends to 0. 1 minus cos let's do mx upon 1 minus cos nx. Okay, because if you can do this, then 2mx 2nx can also be done. Okay, that one I'll give you as a practice. So same thing, limit x tends to 0, the numerator become 2 sine square, half of the angle is mx by 2, denominator becomes cos square nx by 2, sorry, not cos square, sine square, that is also sine square, and that's also 2 sine square. 2 cancels, so limit x tends to 0. You have solved this kind of question, sine square ax by sine square bx. What was the answer? A square by b square. Now this time, if you want to go through the basic part, yes, you can do, but this time I want to increase the speed here. So if you are doing this in an objective, so you need to increase the speed. So sine square by cos square, effectively what happens is this factor squares come, so basically m by 2 whole square upon n by 2 whole square. Okay, so that becomes m square by n square. If you want, you can take few steps also, won't make many difference. Okay, but I'm comparing it with this question, sine square ax by sine square bx. The answer was a square by b square. Same thing will happen here, m square by n square. Okay, all right. So for practice, you can try limit x tends to 0, 1 minus cos 2mx upon 1 minus cos 2nx. Okay. And the answer of this is also m square by n square. Okay. Next, one variation and one very important type of question, limit x tends to 0. This time you have tan x minus sin x by x cube. The problem is that the identity is sin x by x, not sin x by x cube. So how will you solve that? Okay, so the moment I see tan here, I can think of this as sin by cos, so let's use that. Okay, so this becomes limit x tends to 0, sin x by cos x minus sin x by x cube. Take sin common and then take the LCM in the numerator. Sin x is common in the numerator, so you will be left with 1 by cos x minus 1, which becomes 1 minus cos x by x upon x cube. Okay, I'll get this expression slightly below. So this becomes limit x tends to 0. Now I'll rearrange it. Sin x, 1 minus cos x, get a single denominator, that is x cube into cos x. Okay, now see what happens here. You know sin x by x can be solved, so instead of writing x cube, I am writing this as x into x square. So this particular limit can be solved easily. And 1 minus cos, use x square in the denominator, this is also just to be solved. Okay, so limit x tends to 0. So this will be, let's write down still, limit x tends to 0. Sin x by x is 1, 1 minus cos x by x square. You can solve it again, but I already know this is 1 by 2. Okay, learn it. 1 minus cos x by x is 1 by 2, x square is 1 by 2. You learned it. And cos x, and see, everything pretty much here is solved. Limit is x tends to 0. Try direct substitution. No. So 1 into 1 by 2, cos 0 is 1, so that is 1 by 2. Remember, direct substitution always work as long as you are not, as long as you are getting a defined value. It should not be not defined, then it's okay. Sometimes the same question comes in a different form. Limit x tends to 0, tan x minus sin x by instead of x cube you are given sine cube x. Now what do you do is solve the denominator first and you'll see what happens. Tan x minus sine x by sine cube x. Now sine cube here is alone, so what I can do is I divide this by x cube, then multiply this by x cube. Sine x by x is 1, so sine cube by x by sine cube x by x cube also will become 1. Okay, or you can do the whole cube, then it will become sine x by x. So limit x tends to 0, tan x minus sine x by x cube, and this is now the previous question. If this is the previous question, answer is 1 by 2, so no need to solve it again. Just understand the idea that they can give you tan x minus sine x by x cube also or sine cube also. Okay. Now for variation, what you can do is you can practice this with limit x tends to 0, tan 2x minus sine 2x by x cube. Practice this. Same idea. I'm giving you the answer. Answer for this is 4. Okay. Try to solve this on your own. Let's look at few more variations how to use trigonometric limits. Limit x tends to 0, cos ax minus cos bx by x square. Okay, what we can do here is see, you have seen that 1 minus cos upon x square can be solved. Okay, but there is no 1 minus here, so what we'll do is whatever is required will generate that. Well, limit x tends to 0, I'm writing 1 minus cos bx. Okay, I'm writing cos bx first. Okay, and then plus cos ax minus 1. Look at the expression, ax. One second, I'll write it like this so you will be able to understand better. I've just changed the order, minus cos bx first, cos ax later. Now what I'll do is I'll add 1, then I'll subtract 1. Okay, and then denominator is x square, so let's split in two parts, x square, x square. This can be solved. Okay, limit x tends to 0, this become 2 sine square bx by 2 upon x square. Okay, and this can be rearranged like this by taking negative common. You can rewrite this as 1 minus cos ax by x square, and then you can further solve this. Let's solve it. Limit x tends to 0, let's adjust sine bx by 2 upon x, first of all whole square, minus this 2 sine ax by 2, sine square ax by 2 so like this. Okay, pretty much both the expressions will look like same. Adjust it, we need bx by 2, so bx by 2 adjusted. If I am dividing it here, I need to multiply it also inside the square, so I'll multiply it by bx by 2 separately. Same thing here happens here also. I will multiply it by, I need ax by 2, so I'll write a by 2 here. Oh, I've written only a by 2 so I'm writing bx by 2. Actually I've adjusted only b by 2 so I'll write b by 2 in the numerator. Same thing here, a by 2 in the denominator, so adjust a by 2 in the, one second, a by 2 in the denominator, so a by 2 in the numerator as well. Okay, now I'm highlighting this sine something upon same something, this is sine something upon same something, they become 1, so this becomes 2 into b square by 4 minus 2 into a square by 4. Okay, whole square was there, so that's b square minus a square by 2, that's the answer. Okay, It's not the only approach. What you can do, I'll give you one alternate approach. You can try that, or use cos c minus cos t also. You can use that also. A single question can be solved in multiple ways in maths. So it's not a necessary condition that you have to follow this method. You can use cos c minus cos d, and you should be able to do that easily. Okay. Let's see the next one. Limit x tends to 0, sine 2x plus sine 3x upon 2x plus sine 3x. Okay. So for this question, what we'll do is, first of all, x is not there with sine 2x, so let's adjust 2x, 3x is not there, so adjust it 3x, here also 3x. Limit becomes 1, limit becomes 1. Okay, so 1, 1, 1. So in the numerator, it'll look like 2x plus 3x. Denominator will also look like 2x plus 3x. Both are same, so basically 1. Okay. So for these questions are very quick to do as such. It's just that your idea should be correct. The first step is crucial in maths a lot. Sometimes the first step is easier, sometimes it is typical. Let's see the next one, and I think what you can do is you can just take a pause and see how quickly you can solve this one, because it is also the same idea. Okay. Done. Let's see. 5x, so adjust it by 5x into 5x, by 6x into 6x, by 5x into 5x, by 3x into 3x. So what do you see? You see that it is becoming 5x plus 6x upon 5x minus 3x. So basically 11x by 2x, that's 11 by 2 is the answer. Okay. I've written. Okay. Done. I think that's pretty much it. All right. One tricky question, because the problem with that question is that the formula that I gave you, there is something hidden in this formula. I'll tell you that. When you are doing a sin x by x, this should be in, this is an angle, na? So this should be in radian. Okay, this one also should be in radian. Even if the question is not stating that, this formula is not stating that, but you should know that the standard unit of angle is radian. So this angle should be in radian. Now look at one question. Sometimes it is often misinterpreted a lot. The question is limit, once again. Question is limit x tends to 0, sine x by x, but it is in degree. This x is in degree. And the reason why students misinterpret this a lot, because the moment they say this, they have the tendency to read it like x raised to power 0. And there then I think you cannot solve this, because sine 0 is, sorry, this will become sine 1. You don't know the value of sine 1 degree. Or so sine 1 effectively you don't know. And problem is denominator is still 0. So first of all, let's convert this into radian, because in order to apply the property, this becomes sine. How to convert into radian? Multiply by pi by 180. So pi by 180 into x. Now this becomes radian. And denominator is x. Now use the same concept, something upon same something. So pi by 180 in division. So pi by 180 in multiplication. This limits get solved as 1. So what's the answer? Pi by 180. Okay. Don't say for this answer is 1. The answer is pi by 180. All right. Now we'll continue with the trigonometric limit. It's just that now I'll not give you limit as x tends to 0. The concept here is now what if the limit is some x tends to a. Now how to deal with that? Let's see. It's working now. So in order to convert any limit x tends to a fx, if you want to make this as limit x tends to 0, you cannot make x tends to 0. So somehow you have to change the variable limit h tends to 0, replace it with a minus h, or limit h tends to 0 a plus h. Pretty much this is what you have studied in left hand limit and right hand limit. Okay, this is left hand limit, na? A minus h, if you put it just less than a, and right hand limit just more than a. So use any one. Mostly you will be using a minus h, but if you want you can use a plus h also. There is no constraint. So let's see what is the benefit. Limit question is limit x tends to pi sine x upon pi minus x. Okay, so let's change it. First of all, it converted in h, limit h tends to 0, replace x with basically a minus h means pi minus h. Replace it with pi minus h or pi plus h, your call. I'm replacing it with pi minus h. Okay, so pi minus h. Okay, so what is sine pi minus h? Sine 180 minus theta, basically same as sine theta. So sine h, limit h is tending to 0, and denominator becomes pi will cancel and negative becomes positive. So limit h, denominator becomes h. So now it is limit h tends to 0 sin h by h. It is pretty much looking like the formulas. Limit x tends to 0 sin x by x, only the name of the variable is different. So this also becomes 1. Okay, all right, this is how you use it. Okay, let's see a few more questions based on this so that you get comfortable. Limit x tends to pi, okay, by 2 cos x minus pi minus 2x. Okay, convert it first of all in terms of h, limit h tends to 0, replace x with pi by 2 minus h. So cos pi by 2 minus h upon pi minus 2 into pi by 2 minus h. This becomes limit h tends to 0. Cos 90, pi by 2 is 90 na? So cos 90 minus theta is sin theta, means sin h, upon this when multiplied by 2 pi by, it will become pi will cancel, and negative 2 multiplied by negative h, so 2h. So sin h by h is 1, so answer is 1 by 2. Okay. All right, let's see one more. Limit x tends to pi sine 3x minus 3 sin x upon pi minus x whole cube. Okay, so let's convert it first. Limit h tends to 0. Okay, so sine 3 times, replace it with pi minus h minus sine 3 sine pi minus h upon, it's getting clumsy, 1 second, Let me write it. 3 sine pi minus h upon pi minus h whole cube. Okay, let's open it easily. Limit h tends to 0 sine 3 pi minus 3h minus sine pi minus h you can solve. We'll solve together. Sine pi minus h, let's write it, upon, if you open the bracket inside, pi will cancel, negative negative becomes positive, so plus h cube. Let's solve it. This is 3 pi minus h. This is easy to solve, pi minus h, so let's solve that first of all. And what you can do for this is, I'm solving it separately so that the steps are pretty much matching. Okay, sine 3 pi minus 3h can be written as sine 2 pi plus pi minus h. Okay, consider this as theta. So 2 pi means 360 degree. There is no effect of rotation. 360 plus na, so no effect. So this becomes sine pi minus h. Pi is 180. 180 minus theta is sine theta. So sine h. Okay. Sorry, 3h was there na. So 3h. Okay, so 3h will come. So this becomes sine 3h minus 3 sine h by h cube, limit h tends to 0. Okay. So far the question is okay. But you see the one problem. If you want to see it properly, for the timing, you can analyze this as, this is looking like 3x. So somehow we have to use the formula of sine 3 theta. What is the formula of sine 3 theta? That's 3 sine theta minus 4 sine cube theta. Okay. So I have to expand this. Why? You'll see in the next step itself. Limit h tends to 0. 3, or you cannot even subtract them. The property also cannot apply. So 3 sine h minus 4 sine cube h minus 3 sine h upon h cube. The problem with h is you might be able to not identify it easily. So try to think it as x. This sine 3h cancels. Effectively you have limit h tends to 0 minus 4 sine cube h by h cube. So what we can do is, we can combine this cube. I'm rewriting this as sine h by h whole cube. Sine h by h is 1. So what is the answer? Minus 4 is the answer. Okay. This one I have solved. I'll give you one question for practice. Same idea. Limit x tends to pi by 2 cos 3x plus 3 cos x by pi by 2 minus x whole cube. The answer for this is 4. Okay. Practice on your own. So now you know how to basically manipulate these kinds of expressions also. Okay. All right. Let's take few more examples. Limit x tends to pi by 2 cot x by pi by 2 minus x. Very easy questions as such. Just need to know the concept of conversion of limit. If I convert it to limit h tends to 0, I have to replace x by pi by 2 minus h upon pi by 2 minus pi by 2 minus h. What is cot 90 minus theta? Tan theta. And denominator becomes h. The question is limit h tends to 0. So tan h by h is 1. Okay. All right. Done. That's okay. We're done with this trigonometric limit. Next, let's start with exponential limits. Okay. Exponential and logarithm limits. So again, the idea is pretty much same as the trigonometric idea. It's just the expression will look slightly different. One standard formula: limit x tends to 0, a raised to power x minus 1 upon x is, answer is log a. Second thing, limit x tends to 0, e की power x minus 1 upon x again is 1. Okay. Third logarithmic will come, it will goes like this: limit, log I've written, limit x tends to 0, log 1 plus x by x is also equal to 1. Okay. If any variation will come, I'll write it here. Okay. Let's see the questions. The idea is still the same. Remember that the formula will not, the questions will not be as straightforward as this. The idea will be a raised to power something upon same something, e raised to power something upon same something, log 1 plus something upon same something, like the one that we have used in trigo. So we have to adjust as per the trigo. Let's see the questions. Let's start with an easy one. Okay. Limit x tends to 0, 2 raised to power 3x minus 1 upon x. Okay. Now, if you look at this, it is clearly matching with the first one. Okay. Okay, I forgot to tell you about e. You must know what's e although, but still I'll cover what's e. E is called Euler's constant. Okay. And the value of this is approximately 2.7. Okay. Basically, it's a number like pi. Pi is like 3.14. Euler's constant is 2.7. So if only e is there, then only this is the formula. Otherwise, any other number comes: 2, 3, 4, 5, root 2, root 3, root 5, something, anything can come. Answer is this, log a. Okay. So 2 raised to power 3x. So use the same idea. Something upon same something. So 3x is not in there. So let's multiply 3, then adjust 3. So basically this is a standard limit as per here. This becomes log 2 into 3. So basically 3 log 2. Okay. Remember that this log 2 is multiplied by 3. So 3 log 2. Okay. Let's see one more question now. Limit x tends to 0, a raised to power x minus b raised to power x upon x. Okay. Okay. So what do we need? In order to apply this sort of property, we have a raised to power x minus 1. That's not here. So whatever is not present, we'll generate it. Limit x tends to 0, a raised to power x minus b raised to power x. 1 is not there. Let's generate minus 1. If I've generated minus 1, to adjust, I'll generate plus 1. Okay. And then the denominator x. Okay. Let's split the denominator also. No? Let's split the denominator here and here. And what you do is you take negative common. If you take negative common, what will happen? The signs will change. That means this positive one will become also negative one. Now this is looking like this formula. The answer for this is log a. The answer for this is log b. Okay. Now there is a property. Although for now, if you know the log, you should know the properties. If you have ever studied anything closely related with log, you should know this property that log a minus log b is log ab. Okay, right now I'm writing this as a property. We'll separately discuss this properties of log in differentiation. Okay, so log a minus log b, I'll give you the basic log. If we are doing subtraction of logs, it becomes log a by b. If you are doing addition of log, it becomes multiplication, single log ab. So for the time being, if you know it, good enough. If you don't, just take these as a formula for now. I'll discuss this in detail when we'll talk about differentiation. Okay, all right, let's look at the next question. Limit x tends to 0, a raised to power x minus b raised to power x upon sin x. Okay, same idea as the numerator. It's just that denominator is sin x na. So let's first adjust sin x. Limit x tends to 0. Okay, sin x, what does it need? Upon x. So multiply by x. This becomes 1. So now your question becomes same as the previous one. A raised to power x, b raised to power x upon x. This is the previous question that we have done, and the answer is again same as log a by b. Okay, remember that this is like this, that a and b are present inside the log. Okay, all right, let's see another question. Limit x tends to 0. These are not good. Let's see this one. Tricky. Two raised to power 3x minus 3 raised to power x upon sin 3x. Use these. Okay. What will you do? This time again, the idea is still regarding the breaking of this. First of all, let's adjust with this sin 3x na. So 3x divided by 3x multiplied by 3x. This particular limit becomes 1. So now we have a simple question. Limit x tends to 0. 2 raised to power 3x minus 3 raised to power x upon x. So we have to do the same adjustment. Subtract 1, add 1, then take bracket, then replace this with negative. And denominator also you'll split in two parts. Upon x upon x. This becomes standard form. Now, limit x tends to 0. Now, let's adjust it here only. Next adjustment is something 2 raised to power something upon same something has to be there, na? Minus 1 upon same something. So 3 is not there. So let's adjust 3 also now. So divide by 3, multiply by 3. Okay. And this limit and this limit now we can solve. So 3 into this becomes log 2 minus log 3 separately. This time we cannot combine. Remember that log a minus log b can be only done if the coefficients of log is 1. It is 3 log 2, so you cannot do this. You cannot adjust it. Okay. All right. Look at one example. This is slightly tricky, but the question is limit x tends to 0, 10 raised to power x minus 2 raised to power x minus 5 raised to power x plus 1 divided by x tan x. Okay, lot of expressions. The moment you see x in power, you should know that a raised to power x minus 1 concept will be used. So first of all, let's deal with the easier part. Tan x by x into x, and this becomes 1. So the question becomes limit x tends to 0. Now 10 is not a prime number. I can write this as 5 into 2. So the power will be distributed 5 raised to power x, 2 raised to power x minus 2 raised to power x minus 5 raised to power x plus 1. Now while doing this, you will see in the next step. So denominator becomes x into x. This is 1 na? So x into x becomes x square. Start taking common from these two. Okay. If you take common from these two, you'll see limit x tends to 0. 2 raised to power x is common. What do you get? 5 raised to power x minus 1. And pretty much this expression is same, it's just that signs are different. So you take negative 1 also common. So that also becomes 5 raised to power x minus 1 upon x square. And somehow we have factorized exponents also. 2 raised to power x minus 1, 5 raised to power x minus 1, and denominator is x square. I can write x separately 2 times. For this one, we know the limit answer is log 2, and this one is log 5. So log 2 into log 5, remember, not log 10. Okay, there is no property for multiplication of log. Let it be log 5, log 2 into log 5, nothing. Let it be. Okay. All right. Next question. Let's do limit x tends to 0 e raised to power minus x minus 1 upon x. Okay, I think you should know this now. The idea for adjustment is something upon same something. It's not there. So what do? You adjust one negative here and put a negative here also. So what is e raised to power something minus 1 upon same something? The limit is 1 na? So the answer is minus 1. Is as simple as that. Okay. Same ideas in e raised to power x also. Limit x tends to 0 e raised to power x minus e raised to power minus x upon x. Okay. So split it in two parts. Limit x tends to 0 e raised to power x, you need minus 1, write down minus 1 upon x, and for this also minus e raised to power minus x, then plus 1, taking common, this becomes minus 1 upon x. This one we know 1, this one we have just solved, that's minus of minus 1. The answer is 2. Okay. This one answer is 1, this one answer is minus 1. We just solved now. Okay. Look at one more variation. Like, trust me, like I am giving you so many questions for practice, but it's not the ultimatum. Means these are not the end. Questions will not be from here. The ideas will be from here. Okay. Add pen. All right. Let's see one more idea. Limit x tends to 0 e raised to power x plus e raised to power minus x minus 2 upon x square. Okay. This time splitting will not work. One idea could be like you can generate e raised to power x minus 2 can be written as minus 1 minus 1. So you might think like I can write e raised to power x minus 1. Okay. Plus e raised to power minus x minus 1. Okay. And then split the denominator. But the problem is denominator is x square. This is not an identity, or this is not the formula. So that doesn't work. We need something else. What do we do? Let's simplify the negative power, because what you have done in the earlier classes is whenever you see negative power you try to make them positive. So let's solve it. So e raised to power x plus 1 upon e raised to power x minus 2. Let's take the LCM. It becomes e raised to power x, e raised to power 2x plus 1 minus 2 e raised to power x upon x square e raised to power x. I've joined the denominators, both of them. Okay. The question is limit x tends to 0, limit x tends to 0. I'm rewriting this now. E raised to power. Oh, no, don't write like e raised to power this. E raised to power x into e raised to power x. Write down like e raised to power x multiplied 2 times. So I can write whole square. Okay. Now why that is beneficial? Look at this. A square. Okay. Let me highlight. A square. 1 is 1 square. So b square. Minus 2a and 1 can be written na? ab. So you see the identity of a minus b whole square is there. I'll rewrite it properly. E raised to power x whole square plus 1 square minus 2 into e raised to power x into 1. Is it now looking like e raised to power x minus 1 whole square identity or not? Okay. So algebra is again merging with exponents also. So limit x tends to 0, e raised to power x minus 1 whole square is there, denominator is x square, so I can join them together, and there is e raised to power x left. The reason I joined them is because this is a standard limit which is 1. So 1 square, okay, limit is h tends, sorry, write it in the I'll write it below. Limit x tends to still 0. 1 square, 1 upon e raised to power x. Now what we do? We have already solved one limit. Let's try direct substitution. If nothing works, try direct substitution. Put 0. E raised to power 0 is, anything raised to power 0 is 1. So effectively 1 upon 1, that's your answer. So 1. Okay. All right. So for log also, let me show you a few examples. Like log, yeah, suppose you get 1 plus 2x, okay, upon x, and the question is limit x tends to 0. What is the identity that I wrote? 1 plus x, na? Again, you write 1 plus x or x plus 1, it is same thing. So don't get confused with the order of the numbers. Limit x is tending to 0. So same idea, something upon same something which is not here. So let's adjust to 2. This becomes 1. So 1 into 2 is 2. One step question. Okay. Okay. Let's see one more question. Limit x tends to e. Let's merge few concepts. Log x minus 1 upon x minus e. First of all, limit is not x tends to 0. Let's convert it. How do we convert? We convert it into limit h tends to 0. Replace x with, this time, e minus h. So log e minus h minus 1 upon x minus e. Na? So e minus h minus e. So negative e cancels. Okay. Limit, this is slightly tricky because one concept now that is required here. which you should know. Again, those who have studied log slightly, they must know log e is 1. Okay, in maths log e is 1. So I'll rewrite this as log e minus h minus log e. Now why I'm doing this, you will understand in a bit. Now again, the property log something minus log something. Whenever subtraction happens, log goes in, the number goes in division. Okay, we just studied the property above. So it becomes single log of e minus h limit h tends to 0 log e minus h upon e upon minus h. Okay, let's rewrite again. Limit h tends to 0, properties are used. Okay, so log, this becomes, I can split the denominator, so it becomes 1 minus h by e, okay, upon minus h. Now remember, first of all, let's relate the property. Let's write the property. The property was log 1 plus x upon x. Limit was x tends to 0. So first of all, plus has to be there. Okay, there is negative, so we have to readjust now. So I'm rewriting this. Limit h tends to 0 log 1 plus h by minus e upon minus h. Okay, instead of question being in x, the question is in x. So look at the question now. Log 1 plus x, this is x. Okay, so we have to focus on the coefficient something basically upon same something. It's not same, so let's adjust. What do we need? E in the denominator with negative. Negative, let's remove it here, put it here. Negative you can do up and down, no issues. Since I have adjusted e, so I have to balance it out. Divide by e, so multiply also by e. And this becomes 1. So answer is 1 by e. Interesting question. Slightly tricky also, not as simple as I was expecting. Okay. From examination point of view, specifically in MCQs, there is one more form as such. Okay. I'm not giving any heading or something. There are some particular case that you have to understand, and the questions will be usually based on those. Okay. The property goes like this. Limit x tends to a 1 plus fx means 1 plus anything, some function of x raised to power 1 by gx. Okay. No, it will complicate things. We'll do this limit separately. I think this one will require a combined ideas. I have to collect those ideas all together. Okay. So far till exponential it is basic. Okay, so we have done so many methods. Let's recall. We have the first idea, that is direct substitution. Okay, this is majoritively you will doing directly substitution. Then if it doesn't work and there is algebraic identities you can do, then do factorization. If you can do that, if a square root is present, do rationalization. Okay. Then you have one standard limit x raised to power n formula. Okay. Then you have infinity's limit, then you have trigonometry limit, then you have exponential and log. It's more than enough as such. The topic as such never ends. It limits a very lengthy topic. Okay. The one I'm talking about, the variation, so I'll cover that separately, okay, in some other class. This is pretty much basic so far. Let's end the session here. Okay, this was a long class. Okay. Class is over. See you in the next class. Good day.